kids, in this lecture I'm going to teach you about the quantum numbers. Now first of all, quantum numbers are those numbers which are used to address the number of electron in an atom. Now we know that an atom consists of the shells, the K shells, the subshells, the orbitals. Now for that calculation we're going to use the quantum numbers. Now the quantum numbers has maximum 4 types, or we can say that we can define the atom or electron or shells of the atom by 4 ways. First way or first type or first step is principal quantum number. Now principal quantum number explains us the size of the shells, the energy of the shells, the number of electron of the shells. It is denoted by n. Now we should learn that what is denoted by n and what is denoted by s and what is denoted, like we have to memorize that to make it clear. And possibilities can be that the students also stuck in that what is n, what is l, and why here we're putting we are n, and now that way you should memorize that what is n. Secondly, the formula to find the shells or principal quantum number is 2ns. Now you will be thinking that that's the same formula to find the shells. So exactly, it is the shells. Principal quantum numbers means the shell of the electron or the shell of the atom. Now when we have to describe the shell of the atom, we're gonna just say that we are describing the principal quantum numbers. Now we know that the shells are K, L, M, N, O, P, Q, and this is all like so on. So here the K is the first shell, L is the second one, M is the third, N is the fourth. Now in this way, we're gonna say that if we have to find the number of the shells in an atom, like we are finding the K shell, so we're gonna just simply put the 1 here in the formula. Now here the n is equal to principal quantum numbers, and you should memorize that principal quantum numbers means the numerical that is used to just denote that which shell we are going to discuss. Like which shell is this? It is the K shell or the one, the M shell, second, third, like in this way. So we're gonna just put 2, 1 and square of that. Now we know that the 2 1 is the 2 and 2 square of the 2 is the 4. So here the number of the principal quantum number is 4. Secondly, azimuthal quantum number. This is the most typical quantum number. In this way or in this quantum numbers we discuss about the shape of the, so it is denoted by the L. Now here it ranges to 0 to n minus 1. Now here the n minus 1 is the formula to find out the subshells, which are S, P, D, F and so on. Now to find the subshells we will simply just put the formula number of the shell, which is K. If we want to find out of the K, L, M, let's find out of the L. Now here we will put the L, which is 2. Now 2 minus 1 is 1. Now here we're gonna just simply write that we know that there is a positive 1 and a negative 1. So that's about that another magnetic field. Now let's just make it clear that now here 1 is the number that we will just denote. Now here we should be clear that here 0 is represents the S shell, 1 represents the P, 2, D, 3, F. Now we should be clear about that the 0 is the starting point. Let's move forward. Maximum number of orbitals, like we have to find that how many orbitals are there. So we're gonna just simply put in the azimuthal quantum number, which we have just find from this formula to this, and we will just multiply it by 2 and then just plus 1 and then again multiply it by 2. In this way we will simply find the azimuthal quantum number. Magnetic quantum number. Now magnetic quantum number are denoted by M. The magnetic quantum number are used to find the orientation of the shells or orbitals. Now we have to just make it clear that azimuthal quantum number is denoted by L. Magnetic quantum number is denoted by m. Now here we will simply put the azimuthal quantum number if we are finding the azimuthal quantum number of 1. So we will just find that from the -1 to the +1, how many factors are there. Now we know that from the -1 to the +1 there is only one factor, that is 1. Now we will count the total factors, that is 1, 2 and 3. Now we will be clear that the S shell or the P shell has 3 orbitals in there. If we're going to find out the orbitals of the 2, that is SPD D shell. So we just ranges from positive to -1, -2, 0 and then +1, +2. So in this way we will find the factors 1, 2, 3, 4, 5. Now we're going to say that the D shell has 5 orbitals. So in this way we can simply find the magnetic quantum number. Now here the word magnetic is denoted because it has a positive and negative charge, and you can simply memorize it by this term. Magnetic means positive and negative. Simple. Spin quantum number. Now the word spin explains itself, that it explains as the spinning. Now there it is denoted by as. Now there is a term clockwise and anti-clockwise. We know that if 2 electrons are moving in the same direction, they will produce repulsion. Now by the cause of the repulsion, they will produce, the repulsion forces will be increased, they will repel each other and there would be distance between them. If they will move in anti-clockwise, that's the point of the spinning quantum number. So the repulsion forces would be decreases and there would be some kind of attractive force building between it. Now that attractive force held these 2 electrons or these 2 negatively charged particles to stay together. So in this way it states that when we have to find the spinning quantum number, we will just simply find out, or it's the statement that it should be in moving of the anti-clock or clockwise or the opposite direction. And that's all about today's lecture.